Mohon perhatian, acara akan dimulai. Yang terhormat, Dear Honorable Speaker, Research Fellow of Advanced Communication Engineering Center of Excellence, Universiti Malaysia Perlis, Associate Professor Insinyur Dr. Muzammil bin Jusoh, and Research Fellow of Center of Excellence for Renewable Energy, Universiti Malaysia Perlis, Insinyur Dr. Syahrun Nizam. Welcome to Indonesia, welcome to our beloved Universiti Mercu Buana. Yang kami hormati, Direktur Akademik dan Kemahasiswaan Universitas Mercu Buana, Bapak Rizky Briandana M.Com PhD, jajaran Dekanat Fakultas Teknik Universitas Mercu Buana, Bapak Ibu Pimpinan, Guru Besar, Profesor, dan juga tamu undangan serta seluruh hadirin yang berbahagia. Assalamualaikum warahmatullahi wabarakatuh. Good morning, selamat pagi, salam sejahtera, Om Swastiastu, Namo Buddhaya, salam kebajikan untuk kita semua. Puji dan syukur telah kita panjatkan kehadiran Allah Subhanahu wa Ta'ala, karena limpahan rahmat dan karunia-Nya kita dapat bersama-sama hadir, baik yang hadir secara langsung di dalam ruang auditorium Harun Zain dan juga bergabung bersama dengan kami melalui ruang virtual Zoom dalam acara yang sangat luar biasa, yaitu International Guest Lecture on Microwave and Renewable Energy, Senin 20 Juni 2022. Mengawali acara pada hari ini, marilah kita menyanyikan lagu kebangsaan Indonesia Raya, dilanjutkan Mars Universitas Mercu Buana. Singing Indonesian National Anthem Indonesia Raya, continue Mars Universitas Mercu Buana. Hadirin dimohon berdiri.
Patriaku mengawal tekad dan mau
Silahkan duduk kembali. Pray will be led by Mr. Muslim STMT. Pembacaan doa akan dipimpin oleh Bapak Muslim STMT. Kami silakan.
Assalamualaikum warahmatullahi wabarakatuh. Padahal kita berdoakan keyakinan agama Islam, bagi yang di luar agama Islam bisa menyesuaikan. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan yuwaffi ni'amahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhika karim wa azimi sultani. Allahumma sholli wa sallim ala sayyidina Muhammad wa ala ali sayyidina Muhammad. Allahumma akhrijna min zulumatil wahmi wa akrimna nuril fahmi waftah alina bi ma'rifatil ilmi wa sahhil lana abwabal fadlika ya arhamar rahimin. Ya Allah, ya Tuhan kami, keluarkanlah kami dari kegelapan perasaan, limpahkanlah kepada kami kemuliaan dengan cahaya kecerdasan. Bukakanlah kami untuk memahami ilmu pengetahuan, karena Engkaulah yang mengajarkan kepada kami apa yang belum kami mengetahui sebelumnya. Ya Allah, ya Tuhan kami, bukakanlah pintu-pintu hikmah-Mu dan limpahkanlah karunia rahmat-Mu kepada kami selama kami mengikuti acara kuliah tamu internasional pada hari ini, agar kami dapat menerima segala ilmu sehingga dapat meningkatkan wawasan kependidikan dan ilmu pengetahuan kami, agar kami termasuk para hamba-Mu yang berkualitas, terampil, dan profesional dalam mengelola dan mengembangkan pendidikan dihadapkan berbagai macam tantangan dewasa ini sebagai upaya mencerdaskan kehidupan bangsa. Ya Allah, dengan karunia kemuliaan dan kasih sayang-Mu, wahai Tuhan yang maha pengasih lagi maha penyayang, Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Wassallallahu ala sayyidina Muhammadin wa ala alihi washabbihi wasallam. Walhamdulillahirabbil alamin. Sekian dan demikian. Mohon maaf atas kekurangan. Bila taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Next agenda speech by Head of Master Program of Electrical Engineering Universitas Mercu Buana. Acara selanjutnya sambutan dari Ketua Program Studi Magister Teknik Elektro Universitas Mercu Buana kepada Dr. Umaisaro SST. Kami silakan.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. Yeah, thank you for each of you for being here today. It's such an honor for me to speak on behalf of the organizer. Before we get started, I'd like to express my appreciation for our speakers, Prof. Muzammil Jusoh, as a research fellow of Advanced Communication Engineering, Universitas Malaysia Perlis, Dr. Syahrun Nizam, as a research fellow of Center of Excellence for Renewable Energy, Universitas Malaysia Perlis, welcome Prof. And also Dr. Rizky Briandana as a Director of Academics Universitas Malaysia Perlis, and Dr. Mawardi Amin as the Dean of Faculty of Engineering, Universitas Mercu Buana, and our moderator, Dr. Harris Woyo. all lecturers and our beloved students of Universitas Mercu Buana. Thank you for your coming. Actually, this is our experience after we have facing a pandemic together. This is our experience to hold hybrid webinar. So in this international lectures, we will listening one or two explanations about microwave technology and also renewable energy. Okay, thank you again. I'm behalf of the organizer. Thank you for your coming and enjoy. Semangat pagi. Wassalamualaikum warahmatullahi wabarakatuh.
Next, opening remarks from Director of Academic and Student Affairs Universitas Mercu Buana. Selanjutnya sambutan oleh Direktur Akademik dan Kemahasiswaan Universitas Mercu Buana kepada Bapak Rizky Briandana MKom PhD. Kami silakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Dean of Fakultas Teknik, Bapak Dr. Mawardi, and also all the lecturer, head department, and also all the students in Prodi Teknik Elektro, and also the Honorable our guest today, our special guest, Associate Professor Dr. Muzammil, and also Dr. Syahrun Nizam. Selamat datang, Prof. Senang sekali jumpa kembali dengan Prof. Alhamdulillah. Selanjutnya yang terhormat kepada Profesor Dr. Muntri Kalaidrus sebagai guru besar Fakultas Teknik dan juga guru kami semua. Alhamdulillahirrahmanirrahim. Wassalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi washabihi ajmain. Puji syukur kita panjatkan kehadirat Allah Subhanahu wa taala. Alhamdulillah, hari ini kita menyelenggarakan conference seminar internasional dengan special guest dari Malaysia, dari UniMAP yang alhamdulillah bisa hadir di tengah-tengah kita. Tak lupa juga pada peserta yang ada pada di ruang Zoom. Alhamdulillah, senang sekali karena sudah lama kita tidak menyelenggarakan kegiatan seperti ini. Selanjutnya, saya mengucapkan terima kasih banyak kepada Prof. Muzammil dan juga Prof. Nizam. Alhamdulillah, we are very happy because if I'm not mistaken, in 2020 we met in UniMAP. Ingat sekali kita mutar-mutar di UniMAP, kemudian yang tidak terlupakan adalah ketika kita disambut makan yang luar biasa ya Prof. ya. Itu our appreciate to all of you. And inshallah in terms of this activities is part of our collaboration between Universitas Mercu Buana and also UniMAP, dan kami berharap ke depan akan banyak lagi kerjasama, tidak hanya research tapi student exchange, pertukaran dosen dan lain-lain yang diharapkan dapat berkontribusi bagi Universitas Mercu Buana dan juga UniMAP. Saya rasa sekian saja sambutan dari saya yang mengucapkan alhamdulillahirabbil. Semoga kegiatan ini dapat berjalan dengan lancar. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Selanjutnya kami mengundang para speakers dan juga Bapak Rizky Briandana dan juga seluruh hadirin yang hadir di dalam ruang Haruzen untuk berfoto bersama terlebih dahulu. Kami mengundang Pak Rizky Briandana dan juga para speakers boleh berdiri di sebelah sini, dan juga kepada hadirin yang hadir untuk berdiri di posisi masing-masing untuk tetap menjaga jarak satu sama lainnya. Yang berada di sisi kanan dan kiri boleh merapat ke bagian tengah. Prof. Mudrik kami undang boleh di depan. Ibu Umay Saron selaku ketua program studi. Ya, Pak Muslim boleh. Okay, we will take picture. Boleh dikasih aba-aba. Oke, boleh gaya informal mungkin, gaya santainya, mantap, luar biasa, sukses. Baik, terima kasih. Mempersilahkan kembali ke tempat duduk kepada narasumber. Baik Bapak dan Ibu hadirin, baik yang hadir di dalam ruang auditorium Harun Zain dan juga kepada seluruh peserta yang bergabung melalui ruang virtual, kita akan masuk ke agenda berikutnya atau acara inti pada hari ini, yaitu guest lecture. Dan selanjutnya, guest lecture dengan tema Microwave and Renewable Energy akan dipimpin oleh moderator. Dan selanjutnya kepada moderator Bapak Dr. Heru Suwoyo MSK, kami silakan.
Thank you very much, Mas Amir. To the honorable to the honorable first and second speakers we have in this event, Dr. Syahrun Nizam and Professor Muzammil bin Jusoh. To the honorable Director of Academic and Student Affairs, Universitas Mercu Buana Jakarta, PhD. To the honorable the head of Master Program in Electrical Engineering, Dr. Syahrun. To the honorable our senior lecturer who is already among us today, Professor Modric Alidrus. And then the last but not the least, all the lecturers who might participate whether online or offline this event, and all participants. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Welcome to International Guest Lecture organized by a Master Program in Electrical Engineering. My name is Ir.Ts, lecturer from Department of Electrical Engineering, Faculty of Engineering, Universitas Mercu Buana. This is an honor for me to participate and especially to be assigned as moderator here, who will lead the discussion at the core and main session of this event. For that, thank you very much for your opportunity. Well, everybody, today, especially to this session, we are about to get insight and knowledge as well as a discussion that will be delivered by our respectful speakers from Universiti Malaysia, Dr. Syahrun and Professor Muzammil. But as common, before we continue and start our discussion, let me briefly introduce them to you by reading their CV. We start from Professor Syahrun Nizam. His academic qualification: graduate on Bachelor in Electrical Engineering, University Technology Malaysia. Graduate on Master in Electrical Power Engineering, University Technology Malaysia. Graduate on PhD in Electrical Power Engineering, Universiti Putra Malaysia. This is for Dr. Syahrun, yeah. And then second one, this is for our second speaker. We have these are his academic qualification. Graduate on Bachelor in Electrical Telecommunication Engineering, University Technology Malaysia. Master in Electrical Electronic and Telecommunication Engineering, University Technology Malaysia. And graduate on PhD in Communication Engineering, University Malaysia. Professor Muzammil published over 170 technical articles spread across several topics and Web of Science indexed journal, including IEEE Access, the IEEE Antenna and Wireless Propagation Letter, Microwave and Optical Technology Letter, the International Journal of
the International Journal on Antenna and Propagation, abbreviated by IGAP, for Progress in Electromagnetics Research, EIER, and Radio Engineering. Besides that, Professor Muzammil also published more than 80 conference papers. I think that's the reason he holds a Scopus H index of 14. 20? Okay. Yeah. Professor Muzammil research interest includes antenna design, reconfigurable steering antennas, wearable antennas, wireless power transfer, as well as RF and microwave communication system. And then for the following honorable speaker, Dr. Syahrun Nizam, as academician, he has also published over 30 technical articles for English ID linguistics that also spread across several scopus and journal with the name as follows: International Journal of Electrical and Computer Engineering, Advanced in Electrical and Computer Engineering, Material Science in Semiconductor Processing, and Bulletin of Electrical Engineering and Informatics. And for his research, the rest includes electric field, lightning, high voltage, and renewable energy. Right? Well, I think up to this point, we can start our session. Without further ado, to begin this session, let me invite the first speaker we have, Dr. Syahrun. But before that, let me share my greeting to him. Welcome to Indonesia. Welcome to our campus, Universitas Mercu Buana. Well, with first honor, Dr. Syahrun, please welcome. You can start your presentation now. 25 minutes starting from now. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, MC pengajar pengacara Malaysia. Pengacara, lecturer in UniMAP. Mencuba. Yang dihormati lecturer Pak Tiko, Prof Putri, and Ibu Umay. Thank you very much for inviting me to give some speech regarding lightnings. Okay. Actually, my name is Syahrun atau Ashir, from Center of Excellence for Renewable Energy, for the chair in UniMAP, under Faculty of Technology, Faculty of Engineering Technology in Energy Technology in UniMAP. Okay, next slide. Okay, today I am to present about the lightning safety and understanding, because today I need to share with you with the what you call normal language. Hopefully you can understand, not to the alien words for you. Then I can go. I need to convert from alien words to common words. Next. Okay. History of technical research. It comes from the journey from the you will make the time. And then when the Columbus come, Columbus ini awan gelap, awan hitam. Okay, Columbus come and he playing the kite and he need to electric flash into the ground. Okay, next. Okay. Yeah, that one is in the slide. We have lightning phenomena. We have 4 types of lightning. First, common is cloud ground. Okay. In cloud ground, we have 4 types. So, okay, we have a cloud to cloud. I call it intra-cloud IC. Intra-cloud, we have two, inter and intra. Inter within the same cloud, intra within two cloud. You understand? Cloud, first cloud and second cloud, we discharge and we call intra cloud. And another one is cloud to air. Cloud to air is happen when aeroplane or chopper or helicopter go to fly, then lightning come to strike to them. Okay. Okay, type of cloud to cloud CG. We have four types. First, it is negative downward. It is negative upward. It is positive downward, and it is positive upward. Okay. Wait. What? Actually, in lightning research, we call that is positive and negative lightning. But now, I need to explain to you the negative is one term and positive prayer because of positive very huge, very strong. And negative is very small. Yeah, and the amount is very low. Okay. Then it happened, the negative happened, the what it does happen during thunderstorm, during rain. But the positive thing happened not having any rain and waiting for the cloud from come to that rain. Okay, next. Play the video.
Lightning strikes from storm clouds down to the ground. It also strikes up into storms and also out into thin air. Sometimes isolated sparks shoot up out of the ground. Lightning channels sometimes sail in strong wind and take bizarre, unlikely paths through the sky. This video is about the weird behavior of strange lightning. Most of us have seen epic lightning bolts branching from the cloud down to the ground, but have you ever seen lightning bolts branching up? Upward moving lightning, or ground to cloud lightning, often has a strange, smooth, and fluid channel. This type of lightning was extremely rare prior to the Industrial Revolution and is said to have only occurred from mountain peaks. Tall man-made structures help trigger this discharge, and increasing skyscrapers and radio antennas are making this brilliant phenomenon more common. Most lightning discharges occur only in the clouds, never striking the earth. This is called intra-cloud lightning. But sometimes it leaps out into the naked air, and so this phenomenon is called cloud-to-air lightning. During a lightning storm, it's a good idea not to be the tallest thing standing around, but that doesn't mean you're safe if you're the shortest. Lightning seems to have a physics-defying mind of its own and often takes unlikely, erratic paths before striking a random target. Milliseconds before a typical lightning strike, a stepped leader advances from the cloud to the ground. Before reaching the ground, a charged ionic channel called an upward streamer reaches up to meet the leader. When they connect, a massive electrostatic discharge flashes. This particular strike surged through the tree and exploded out the base of the trunk, where it then traveled into a house, frying all sorts of electrical equipment before bursting out the water main on the other side of the house. During some strikes, multiple upward streamers spark up and only one makes a connection. In rare photographs, you can see these lonely upward streamers failing to make a connection. After a strike, the main lightning channel begins to cool and sometimes decays into glowing fragments. This string of dots is called bead lightning or chain lightning. Sometimes lightning photographs have parallel successive flashes or strokes offset from each other. This is called ribbon lightning and occurs when strong winds actually blow the flashing channel through the camera frame. Here's some video of lightning actually sailing in strong wind. We've all seen lightning flicker, but we generally don't see all the flashes or strokes because they happen too fast for the eye to see. Some lightning strikes are said to flash up to 30 times. When you slow video down, you can detect more of the flashes, but this video was shot at 30 frames per second and lightning can hide several strokes inside one of those frames. 480 frames per second will give a more accurate stroke count, but again, it is possible to have several strokes inside one of those frames. The best way to get an accurate stroke count is on one still frame, and for the best results, make sure you take your lens cap off. On a dark, stormy night, open your shutter and pan your camera back and forth like this. If lightning strikes during one of your pans, you'll have recorded and separated the individual strokes. Notice the primary flash is the only one with branches. Perhaps the most mysterious form of lightning is ball lightning, which is said to be a luminous orb that can penetrate walls. Despite the trillions of selfies that are shot around the globe every second, there's no solid photographic proof of ball lightning.
Okay, next. That one is actually.
Lightning strikes from storm clouds down to the ground. It also strikes up into storm.
Next.
Lightning.
Okay. The video show that lightning not only come from top to the down, but it can happen from down to top. Okay. Now we go to lightning potential. We have three potential. One is direct potential, when the lightning direct to the body, the human, will pass to the body and go to the ground. Second is a touch potential, and third is a step potential. Okay, this is common in power system. Okay, I need to tell you about the voltage is the burning, and current is the killing. Are you agree with that? Voltage is the burning, membakar. Current is the killing. Okay. During I do my S3, I research the line. I go to find the line. Something, one day, lightning find me and struck to my left hand. Because I was very sad. My feet sadder than probably very wide. See, the proof is if you mind take my picture during 2008 after F1, very sad. After I got struck by the name, my teeth will become bigger and darker. Okay, this is some joke. Okay. So sometimes when the people struck by lightning, he died because of a current, not the voltage. Lightning contribute high voltage and high current. Okay, next. Okay, that one is a step potential. Step potential, we can engine. We go to the pool and take one rock, and you pull out to the pool, and they have a wave, right? That wave become the voltage. The potential voltage from the higher peak is a very high voltage. The lower is a very minimal voltage. So the difference of the step, it become potential. Okay. When you go outside, for example, in Jakarta, you will have a steady field. We have, okay. That one is one very dangerous area. Then sometimes in Malaysia we got many people go to the hill, climb the hill when the lightning come. So they were very dangerous. Next. Okay, let me say. When you heard the thunderstorm, you need to go inside the building or protect your body. Then more than 80 of lightning strategy within main. Why? During my S2, my lecturer asked my lecturer asked us how become men more struck by lightning. I said the man is more shaitan inside the body. The answer is the men more go outside compared to the female. The player go outside. For example, fisherman go play football, okay, and then make the fantasy trading. The channel of the channel of the lightning can be 54,000 Fahrenheit. So if they struck to the metal will melt. Okay. Yes. Okay. Thunderstorm per year. Okay. Statistical analysis compare the Argentina between 30 to 80 per year. Brazil 40 to 200. Indonesia 180 to 250 flash in a year. And Malaysia we are a little bit high compared to Indonesia. Okay. Next. Okay. If lightning struck to the building, take care. Lightning always struck to the edges of the building. Edges of the building. Do you know why? How to become eliminate the structure building? We need to protect the building. For example, we put the lightning terminal. Okay. Next. This is an example. Lightning struck to the first feature is the cow dead because of step potential, and the second is electronic in Johor Bahru. The damage because of lightning struck at the building. How far lightning? Is how far away is lightning? The lightning. Count rule of thumb is you need to when found the lightning, you need divide by number by 5, get the estimate distance of in miles. For example, you heard you get the flashing, then you need to count 101, 102, 103, 104, 105. Then suddenly found here you hear the sound. So your distance between you and lightning is 1 mile. If more, then you can more safer. Okay, next. Okay, lightning occurs almost occurring in you have a boating, riding horse, riding a land mover, golfing, walking, mountain climbing, and camping. Okay, next. Okay. When the dangerous weather approach what the lightning change, we have lightning safe plan. If you heard the thunderstorm, you need to protect yourself. Go to the protect building. Second is postpone your activities. If we have a schedule to play the football at 5 p.m. Then let me raining happen, so you need to postpone your playing football. Monitor the weather. Okay, in Malaysia we have one app. After this, I will show you. We can monitor our weather. The movement of cloud. Okay, get your safe place. If you have, for example, you riding your motorcycle in the road, you need to find the right place to stop. If not, you can be one of the person who get struck by lightning. Okay, that story, I have experience struck by lightning when I ride my motorcycle in Bali, Kuala Lumpur. That one is very heavy rain and very heavy lightning. Suddenly, I look at my area. We don't have any protection for me to ride the motorcycle. So I can go to the near metro station. Because why I say that, because of they have no more tree and pole. Because the tree and pole become my protection. When the lightning strike to the highest point of this area. So the lightning, if the lightning strike to the tree or pole, I got safety. But now, when I need to go to the presentation, I got struck by lightning in the left hand. Until now, I got numb in my left hand because of lightning. That one, I think not direct strike, but indirect strike. Almost right. Okay. Okay. Next, you need if you have lightning happen in the outside, you need to keep away from your electric equipment. For example, during Prof, he was young. Now he's also young, but at time. Okay. They always use the landline telephone. Okay. That always happen when lightning strike to the line. We propagate through the line telephone and strike to the body of the person. I will show you the news about the Indonesia people playing headphone during the lightning and charge the headphone. Okay, next, this is great application in Play Store, even in Google Store, but it because the area only Peninsula Malaysia and Medan. In Jakarta, no provide the application. Next. Okay, during stop, you need to avoid open area and keep isolated. Then you need to go to protect the site. Take away for metal conductors such as wires and fence. For example, if raining, lightning, you not go to the bus because of the propagation of the water can go to you. Next. Okay. This video in Malaysia happened, lightning happened when no raining there. Okay, you can do. Did you see it? No. Did you see it?
Play again.
Again.
Oh.
At the time, no raining happened. That's called prior lightning. Very good. Next slide. I'll show you the next slide. Okay, this picture showing this struck lightning. It struck to the tree. Okay, this one photo from my friend. No photo. The video from my friend. That if you are lightning raining happen, do not stay at the tree. Okay, below the tree. Okay. Yeah, very dangerous. You need to go to bus stop, bus station, or go to the building. The next. That one is I think very famous in Indonesia, right? In news, they said it happened in Indonesia. Is it correct? Okay. Please view.
Oh,
The
I know.
staff, go to check or whatever.
The thunder.
Tinggi. And luckily, the pump is light. In that. This because of open area. We will start to do. Okay, let's. That one is Mandalika, very famous last year, right?
This year.
This year. Okay, this year.
How much do you love Hervé? It's like a movie out here. Hervé thinks it's a shower and it'll be all right in half an hour. What planet is he on?
I love his positivity. What's quite interesting, when this was announced that they were going to hold a race here at this time of year, the World Superbike race, which is around November time.
How much?
Okay, this one is I think last 2 weeks or like 3 weeks in Perlis, in the Perlis area. We call the Pampat Perlis. One man is struck by lightning and Alhamdulillah got that. And the one is just from the body, the police take the body outside to the victim. Okay, next. Okay, that one is a picture when Michael McQueen and his brother take picture with the Moro Rock. They want people or the even the building, they produce emission, earlier single emission. We can produce the earlier single emission to the lightning to strike to you, and then okay, the course during outside the storm, fiction, I cannot read. Okay. Okay. These are cases by lightning in Indonesia. First, in 2021, and 2021, lightning bolt struck to certified Indonesia in the positive thing, but the survived. Okay, that one is we saw the lightning the video just now. Yeah, second is 25 November. 60 years old Indonesian boy dies after being struck by lightning while playing game on the charging phone. So connect to the power supply and playing the lightning start to the line, transmission line, and the power to the pole and got died. 4 December 2019, one died, 2 injury after being struck by lightning in South Sulawesi. And lastly is 4 killed in Indonesia. They crashed after lightning struck to the plane. Okay. Okay. This is one story happened in the world. What is Somersault? In life, he will instruct the lightning 3 times, and then he died not because of lightning. Okay. Then they buried the body into the grave. Suddenly, the lightning started to crash. The grave got broken by lightning. Okay, next. Okay, another one is got Junior Book of Record, Roy Billion. He got, I think, 5 times struck by lightning, and every time he got injury. For example, the first time he lost a pectoral, the second time he lost an eyebrow, third time he used a shoulder hair, and fifth hair set on fire. The 6 fire to the neck and hair, and many injured with the body. Okay, I think that's all for me, for just introduce you about the lightning. In the lightning research, we have maybe we can collaborate using to do the antennas. For example, for my PhD, I did the parallel plate antenna for electrical field and the magnetic loop for the EMC. Okay, that's all for.
Okay, thank you very much for your presentation. I think it was a great presentation, so it's valuable for us. For you that know about lightning, I think we have to translate to Indonesian. This killer. Killer to thunder, but it's not thunder. Lightning is killer. So by this presentation, we know how dangerous lightning is and how we have to protect our body when the rainy is happen, and how we have to point the open area of lightning, as well as we have to think about metal if it's close for if it's close to us, because even metal doesn't attract lightning, but metal can be guide for lightning. Right? I think that's all about this presentation. I hope this we have. I hope you still have eager to follow the presentation, because we have to move to our second speaker. Probably we will talk and discuss about lightning after this session. I mean the presentation session, because we will have Q&A session at the end of this session. So without wasting time, I think let's continue to the next speaker. Let me invite Professor Muzammil. Good morning, Prof. I think I have to say greeting as I said to Dr. Syahrun Nizam. Welcome to Indonesia. Welcome to our campus Universitas Mercu Buana.
Thank you very much.
And well, with the first honor, Professor Muzammil, please welcome. You may start your presentation now. 35 minutes with the same duration I said and give to Dr. Syahrun. Time is yours.
Thank you very much to Mr. MC. Very good morning to everyone. Assalamualaikum. My greatest, I think we are very good friends, Prof. Bumai, and the other friends. Some others, maybe some other students from who's joining online. So hopefully you will enjoy the session. Thank you very much. I think it's been explained by the Mr. MC. So my name is Muzammil. So I'm attached to the Center of Excellence, Advanced Communication Engineering. Just some sharing about myself. Previously, I was in industry. So I joined Telecom Malaysia Berhad after my first degree. So I joined about 3 years. So my research, my focus work at that time is on antenna and wireless propagations, so microwave link, and some others. But when I joined the universities, so my research is focusing on reconfigurable antenna. So especially on using switches, plus I do involve in RFID, MIMO, IoT, and currently I'm exploring BLE, Bluetooth Low Energy. Yeah, BLE. So you can see some. Sorry, I need to see from my laptop. Can't see a bit far. I need to increase my power, my spec power. Okay. Currently, I'm also working in some industries. I'm working with consultation work as a consultant. Under G2R Sdn Bhd, it's a company related to telco, related to telecommunication, as well as MNF Infra Sdn Bhd. This one based in Puchong. Spectral Solutions Sdn Bhd, Mimos, Mazda Technologies. I also get some job. I'm doing some job for them. At the moment, I'm focusing on this company, MNF, Infra Sdn Bhd. Of course, still in wireless, still in wireless area. So that is our patient. As well as being appointed as visiting by this university. You can see some of them. Just to correct, my current number of scopus paper is 234. No problem. No problem. But maybe we can, I think I will discuss before, we can explore more in terms of publication later on between UniMAP as well as UMB. So a little bit about UniMAP. Next. There's no it's about me, now it's about my university. Our university actually. So we are located at the north side of Malaysia. So the nearest airport is in Penang. That is the nearest international airport in Penang. We are at the northern side, near to Thailand. So we are welcoming all of you to come. I think probably it's been there. Even Prof. Andy also there last time. You can see we have 3 campuses. Our main one is in Putra. That is our main campus. But still we keep in Kanga as well as in Sungai Jusoh. Perlis is the biggest state. I think the 14th biggest state in Malaysia out of 14. Okay, Perlis is the 14th biggest state out of 14 in Malaysia. They don't want to say small. They say the 14th biggest state in Malaysia out of 14. So next, there is about UniMAP. We have so many programs there. Even the number of students is nearly 13,000. We have undergraduates of almost 10,000. So okay, we start about that one. So we are focusing on our title today. So this is the company that I named from the beginning, where I get the knowledge of microwave link last time. So this is a company that I attached to during my industrial training back 2005, 2006. So MTK Communication Berhad, he's a subcon company that doing the installation, not promoting the company, they're promoting the technology. So these are the one who's doing the microwave link That time I experienced do the installation as well as decommissioning of the microwave link. So it means that that time if you have new site, you have to install the microwave link. So we have both sides, we have transmitter as well as the receiver. As well as we are doing decommission, means you decom, you deassemble. You deassemble. In certain cases we bring to the other side, we install, or certain cases we bring to the workshop now. Okay, next. Okay, now we touch about microwave technology. What means or what is the microwave technology? Microwave, you know, I think surrounding you, you can't see. You can see a wave. You can see a wave, but it's there. Electromagnetic is everywhere now. I think if you can see, I think you will feel afraid also. You feel not secure. But luckily you cannot see, so it's still comfortable. Like lightning, you can see. Lightning you can see because of light now. But EM you cannot see. But it's everywhere now. Even now with me, when everywhere. So microwave is a bit is when we talk about microwave, we always think about line of sight. It must has line of sight. If it has any obstruction, of course, it can't happen. So why? Because it has using high frequency beams of radio wave to travel. So this one you are sending normally in a GSM system. GSM system, they have a backbone, microwave link to transfer from one point to another point. You need a microwave link. It will your what you call, it will travel a big far. So even when we talk about wavelength, as well as we are talking about satellite communication as well. If you know the Earth station, the receiving signal from the satellite is using microwave as well. It's a point to point. Even talking about beamwidth, it's a very narrow. And other than that, we are like deep space radio communication. Even we are using radar, radio navigation system, sensor systems, and as well as astronomy. That is a little bit. So this is about history. Next, history of microwave link. Where this coming from? Actually, this is from James Clerk Maxwell. So the very famous Maxwell equation. So this guy, he predicted the existence of invisible electromagnetic wave, of which microwaves are a part in back 1895. So even there is another guy, Hertz, they became the first to demonstrate. So demonstrates the existence of such a wave by building an apparatus that produce, and actually they can detect. So he's the one. And another guys, the other contributors, I think is very well known, is Nikola Tesla, Marconi, Samuel Morse, Sir William Thomson, Lord Rayleigh, and others. So these are a little bit history, and you can see the next one is a traveling over English channel. This is the first prototype that they can experiment microwave relay link across the English channel. So this one is just small one, 3 meter, 10 foot dishes. But still now, bro, they're still using the dish. It's very famous. The dish, because why? It's very high gain when it has a very narrow English. So even I think in Malaysia, we have one company, Astro, for TV communication. So we are using a dish to capture the signal coming from satellite. So another one is during the 1950s, the AT&T long line system of microwave relay. They grew. This is a US-based company. They are developing one of the other prototype regarding the microwave. At the end of my session, I will share a bit of my current work regarding the microwave, as I discussed with Prof last night. We had a very great dinner last night. Next. Okay. When we talk about microwave, of course, the first thing first you have to understand is the frequency. Actually, what is the focus frequency of microwave? As you know, we have so many inside the spectrum. We have so many applications, and the microwave is one of them. You can see the figure. We have non-ionizing, we have ionizing. So want to focusing is on the microwave. The microwave, when we talk about microwave, is from 3 gigahertz to 30 gigahertz. So everything is there. We have K band, KU band, X band, and so others. So the range is between 3 gigahertz to 30 gigahertz. And the others you have remote control, visible line, and so others. So microwave is within that range. So if you go to the next one, the next slide. Okay, this is the basic setup. The basic setup how the microwave link look like. So from there, you can see when we talk about communication, of course we need to know there is someone speak, someone listen. So the someone speak is the transmitter, the someone listen is the receiver. So in between you should have the medium of communication. So when we talk about microwave, of course we are talking about air as the medium of communication. And the most important, it must be point to point. So in terms of range, talking about range, it's vary depending on the I'll tell you later on, because we have a free space equation, FSF, free space loss equation. So it depends on that equation. Apart from, we have so many related frequency and related formulas related, for example, like Hata, Okumura, we have so others. We're talking about attenuation as well. Attenuation also has another formula, relay, and so on. Okay, back to this one. We have a transmitter, we have a receiver, of course we have the medium. So this is the basic setup of the microwave. And one more, it must be point to point. Okay, next. Okay, maybe on the top is the same structure or same diagram as before, but of course it has an indoor unit. When you go down, you have indoor unit for both sides. Okay, okay. The bottom one, it shows a diversified. It has primary as well as secondary. This is very important also. Sometimes why we need this one as a backup. Sometimes the primary down, we have the secondary. I still remember during my time in MPK Communications and we are the one who installed this. We have to climb the tower. Of course, we need safety harness. We need very good helmet. We need safety boots. So we have to climb and bring all those things up to the tower. We don't carry it by our hand. We just need some pulley, and the other side we put. So remember last time we are using Storm, Mitsubishi Storm. This Mitsubishi Storm will help you to pull your equipment up to the tower, depending on the level. Normally the tower, I think the biggest tower that we had last time is 150 meters. Still remember my first time I climbed on. You can feel you have no leg now. Very shaking down. Stay in Kota Damansara, still remember. So they asked me to climb. Then I just climb. But luckily we have a tower that circling you. So you feel safe, a bit safe. Because if you lay back also you have something at the back. Okay. Stay safe. But to reach the tower and to reach the platform, you feel like, wow, very far. Okay. Maybe it takes hours. Okay. You're feeling, but at down, your team will ask you, keep going. So you still from one ladder to another, and luckily we reach the platform, then you feel more comfortable. Okay, that's the experience I think back 2005, 2006. But at the moment I didn't do that anymore. Now we are focusing more maybe on at least on the rooftop. No more at the tower. So that is the experience. So we bring everything up to the tower. So we have to do the installation. Of course, you need a rigger. You need a rigger to do this. Very experienced guy to do installation. Because normally you can see the equipment, all those equipment will be outside the tower. So you need some arm to hold the equipment, especially the dish, very big dish. Same like that one. So we need someone, a very good rigger, is the one who will do the installation. So what you will do is, you have to check, as someone who monitor the work, you have to check either this setting is vertical or horizontal. Don't make mistake, because everything at the back of the dish you can see there is V or H. So if this side is V, the other side should be V. So this side is H, the other side should be H. Must make sure. Actually, in the beginning we make mistake lah, of course. I think newcomers they make mistake, but yeah, times come we avoid this. So why? Because as you know lah, this is a linear propagation. Linear propagation. So you have to make sure everything in line. So once talking about horizontal, so the other one should capture also as horizontal. And the other guy from down in the indoor unit, they will do the checking, especially on the throughput lah, on the reception, whether you are receiving very good or not. Okay, I think that is the critical part lah, critical part when you're doing the installation. Of course, the distance is very far. The distance is very far. Just now I talked about free space loss equation. It's very famous equation. Power received equals to power transmit plus power power received equals to power transmit plus GP plus GR minus free space loss. Minus free space loss. Free space loss is 32.45 plus 20 log P in kilometer plus 20 log F in gigahertz. So these are the basic formula. Easy, because when you want to do the installation, you must know the link budget. So the power link budget. So everything is rely on this one. That's why they know how far the signal can go. So it depends on the distance. I think we have the cikgu here lah, probably. I expect the cikgu lah. Okay, next. Okay, of course, when you capture, you are capturing the RF signal. So RF signal. So in the both side, you should have what we call conversion happen in both sides, either transmitter or receiver. So I believe on the top is the receiver side. Once you receive the RF, you need to have something for down conversion. You should have the oscillator, and the most important thing is your intermediate frequency. So from there you can process now. Actually, down on the bottom, talking about the transmitting now. Transmitting, of course, before you transmit, you should have some amplifier. You can see from there is a block diagram. So from the IF, you will mix with some frequency from the oscillator, and then you will power up. Then you transmit back. So because we need a carrier. Yeah, carrier. So that is the basic about the microwave link. Hopefully you can understand. It's very simple. When we say microwave link, you need to have someone top is a transmitter, someone receive is your receiver, a medium is the air. Yeah, these are the three important things. Okay, one more is the point to point. Must be point to point. If I am facing boundary, okay, boundary can receive clearly. If I am facing this Ibu Umay, then Umay can receive clearly. So it must be point to point, and make sure your polarization, careful on that thing, because we are talking about linear propagation. Okay, next I share with you my current work. Previously, I tried to find some of my pictures during my telecom time. Cannot find. Be the other hard disk. During my telecom also, I handling some project regarding the microwave. I still remember. We are the biggest customer of us is the Department Civil Aviation. It's Jabatan Penerbangan Awam lah. Now they changed to new name CAAC, if not mistaken. That time I'm handling the whole Johor plus Pulau Tioman. Actually, in Pulau Tioman we have one airport handling by Berjaya. You know Berjaya Times Square, the same company. And the Vicenta is a Berjaya. So we have a small airport. Actually, the communication happened between because we have that time during the DCA, we have information learning system, we have Doppler very high frequency omni range, as well as we have another one is ILS something. So the communication happened between the Tioman to the other island, small one, via microwave. We're sending everything via microwave. So you must make sure the point line of sight is there, point to point. So that we explain the time lah. Okay, talking about this one, this is the current work that I'm doing, because although I'm focusing on publication, on some research grant and so on, but I think past two years, my transition is more on commercialization. Correct? We are focusing on developing some system, and we are dealing with industries. So we do some transition. I think past 2 years, I'm doing this research. I think about 1 year now to develop this one. So we divided the whole system as known as Quattro. I name it. Don't ask where the name come. I name it. So we divided into few stages. As you know, the internet coming from the satellite, from the wired technology, from the wireless. So the wired can be from optical or coaxial cable. So wireless normally is coming from the telco. Telco. Here I think you have Telkom Nika. Telkom Sat. Sorry, Telkom Sat. There I think we have Maxis, we have DG, we have Celcom. So we have Your Mobile. Okay, this one we can capture and combining the wired and wireless system. Even the wireless also, I can combine the telco, few telcos. It's not illegal, it's legal. It's legal, because someone asked me, is it illegal? No, we don't do any hacking. It's legal. So what we are doing, actually, that is our main G's lah, our niche lah actually. So that is the critical thing. Normally we hide those things lah. Of course, it's about programming. It's about programming. We have some networking knowledge there. Actually, once we capture, you can capture a bit far, up to 5 kilometers. You can capture from the base station, and then we combine, and then we produce the Wi-Fi internally. For example, like we put the access point, we can cover up to 50 meters inside the building. And for the next stage, next, okay. So we introduced the omnidirectional antenna as for outdoor unit. This one can cover up to 200 meters, 150 to 200 meters. 200, I think the throughput will drop significantly. So the next one, this is the bridging part. Either we can use the sectorizing antenna, 60 radius to certain area, or we can use microwave link to capture to the other side. For example, this is a residential area. We don't need to have a microwave. We just transmit broadcast. But if you need a dedicated, for example, you have one building or one hall, for example, you have to put microwave point to point. For this one, we are using 5 gigahertz as the microwave bridging. So 5, you shoot there. From there, you have a receiver. Of course, you have transmitter, you have receiver capture, and then it will going down inside the go through the access point. So from this access point, you will have internal internet. Okay, next. So this is the full structure. The full packages. Why we divide into stages? Later I show you. Okay, next. We have been installed this one. I think this week we are going to Malacca for fourth place. This is the first one that we installed in January 6th. Actually, talking about this place, it's a bit rural. Don't have any wired technology at the moment, but of course there is a telco. Telco is everywhere. I admit telco is everywhere. the matter of coverage only. If it's strong or not, can the throughput is good or not. Okay, this area we don't have wireless technology, so we have wireless. So that is the model. In between is the model. I always bring my student, my final year student, to join me. So that is my student. Okay, next. Okay, this is a study. It's a site survey. Site survey we did before we do the installation. You can see on the bottom is the where we are focusing at. That is another tower, another base station. Can't see by bare hand, by bare eyes. Next. Okay, actually the distance for this particular real installation for tower 2, sorry, tower. Okay, the semi tower. Okay, the name semi and DPIT is not from me. It's from the system. It's from the system. When you capture, there is name there. So the semi tower 1 tower, the distance is 1.5, whereas the DPIT, the distance is 2.79. You can see that the DPIT can only give you 3G and 4G, whilst the semi can give you 3G. Just for your knowing, at the moment we are in the process to do the sunset from 3G sunset. 3G will be no more. So that's why I took 2.79, because there is 4G there. So because if I take 3G, suddenly sunset, so no point. So I use the other one. Okay, next. Okay, that is the system. You can see on the top, we have a router, we have antenna who capturing, and everything will go inside the building. Okay, next. That one I can say that is stage 1 as well as only stage 2. Stage 1 and stage 2 because you have the outdoor unit. Okay, for this one, in Changlun, maybe from Prof come later I can bring you there a bit near. Changlun is a bit near to Perlis. SIG is took about 2 hours. Okay, this one we install still dish, bro. Still dish because we want to get strong reception. That's why we are using this one. This is a parabolic. This one we take from the nearest base station because at the moment this side they don't have any streaming, any Wi-Fi. So we are capturing this at the nearest base station through one company, Webi, they call Webi. So we capture and we process the signal next, and then we produce the stage 2. So this is the Omni problem. And to my Omni, so it can cover the whole school, Okay, next. Okay, this is another school. Both of us very close to. This is Matri. So this scholar they are using stage 3, which is the bridging problem. The bridging. So actually we are talking to the schools, to the Mude, because they have a very big pipe, 500 meg. You can see the 500 meg as the source. You can see that. So actually they want to transfer that. Actually they want to have internet at the receiver. The receiver is the hostel. So I said to them, no need to have a new subscription, new wired subscription. So we will bring the same pipe, but we divide the pipe, we transfer to the receiver. So we divide 300 and 200. Actually, we can manage the pipe. We can manage the pipe. So we divide, so we transfer. Next. Actually, you can see this is the whole process now. Some pictures related to the. It's a messy work now. We're talking about the cabling. Cabling installation is a messy work. It took, I think, about 3 hours now. Because on the transmitting part, you have to find, talking about point to point, line of sight, right? We have to find a proper place. We have to lay about 50 meters at the transceiver because we are taking the source from the library. You can see the blue one is the library. We have to lay away, but we are using the cable tie only. But we lay about 50 meters and go to to the red circle lah. Red circle is the best place lah. You can go to the higher also can, but waste money lah, because you have to buy longer cable. And so we use first floor, second floor. You can see on the red color. So we shoot to the hostel. We shoot to the hostel. From the hostel also, hostel is second floor. Then we capture. Still you have to lay cable. You see me there. So that is the second level. And then you have to go down. On the left picture is your line outside. That's how you do the site survey lah. Okay, next. Okay, I think that's all about the bridging lah, about the wireless. If you go next, I think there is about the current of my project in industrial grant lah, under the industrial grant. So this one is related to I.
Bang, selamat bang.
So I think I wrap up my discussion. Can you go back? My last slide. Okay. So the bridging is very simple. As I told you, microwave link. Microwave, what you need to have is the transmitter, the receiver, the medium, the point to point, and make sure your polarization is correct. Okay, that's all. Thank you, Mr. MC. Much for the presentation.
I think I don't need to make summary because he did for us. Okay, now I think we have finished and complete our presentation. So let's open Q&A session.
Orang OVC sekelas.
Before that, I think I have to explain the technical of our Q&A session. We have online and offline participant here. For online participant, I think you have to write down your question, and then I will try to read it as the way to transfer the question to our lecture speakers. And then for the offline participants, you just need to raise your hand and you can directly ask to them. I think that's the technique. The first technical I have to say to you, utilizing Q&A session today. But don't forget to mention your name before you ask any question to them. And the topic I think is it was so very well for us. And let's open Q&A session. Time is yours. Baik, saya rasa saya perlu menggunakan bahasa Indonesia. Bagi teman-teman yang tergabung secara online ataupun online pada event ini, silakan bagi yang ingin bertanya. Untuk yang online bisa menyampaikan pertanyaan melalui kolom chat. Nanti kemudian saya akan coba untuk bacakan sebagai upaya saya untuk menyampaikan pertanyaan tersebut kepada speaker kita. Bagi teman-teman yang tergabung secara offline yang dari awal mengikuti pada ruangan ini, silakan angkat tangan dan mulai bertanya. Saya rasa seperti itu. Ada yang mungkin ingin bertanya? Yes. Okay, I think I received a question from our online participant. This is from first name. Okay. We invite from offline participant first. Go ahead.
Let me introduce myself. My name is Adif. I'm from electrical engineering student. I want to ask to Professor Syahrun. In many high-rise buildings in the city, there must be a lot of lighting rods. Lighting rods is need to build a building. Which method is used for the buildings and how it's work? Okay, maybe it's from. Thank you.
I think your question is about protection. Yeah.
Okay.
Is it about protection?
Yes, about protection lighting rods.
Yeah. I think he would like to know how to protect and how to be safely from lightning effect.
Yeah. Thank you. I forgot your name.
Aziz.
Aziz, yeah, Aziz. Okay, actually, the lightning examiner, lightning protection, we have three divided by three types. One is lightning examiner, second is down conductor, and thirdly is grounding system. Okay, lightning examiner, the protection for the top of the building. We can use three types. One is franking method. The third is ESP, earlier streamer emission, and third is fish. I forgot the fish. But in Malaysia, I share with you. In Malaysia, we don't use the ESP because of ESP only use one road only, compared to the Franklin road. We call a conventional protection. Yeah. Okay. If in the government in Malaysia, for example, in our university, university is owned by the government, called the JKR. JKR is one department to manage the building, the government building in Malaysia. They not use the ESP, earlier streamer emission protection, but the Franklin road, yes. And then we have two methods how to protect. We have one is a rolling spear method, and another one is conical method. Okay, rolling spear method is, for example, we have one building here and one building here, and we put ball, the football, and you rolling to the building, and wherever area touch to the ball, we need to protect. Okay, maybe you can call me again, come here to teach you how to design the protection. The one is more on theoretical, but I need to bring the ball here and do some simulation.
Thank you very much for your answer. Is it transferable by you? Yeah, thank you. I think I have to read this question from our online participant, but I think the one I received not only one question. This question is related to our first speaker, Dr. Syahrun Nizam. But I think the first question is already answered by him. And the second one is about, let me try to read it. Is it possible to make lightning to be useful for us in the future? And then the second one, what kind of solution that we can provide to, to say, like to avoid the effect of electromagnetic, do you want become a guide for our lightning? You said to your presentation that metal, which is electromagnetic, it is also guide for lightning. It's not it does attract lightning, but we say that metal can be guide for lightning. Instead, there's effect. It's dangerous for us, and how to reduce that effect. I think that's the point we want our participant wants to ask. And this participant name is Agustini Mahindi. I think our lecturer. Yes, that you may answer.
Okay, thank you, Randy. Agus Randy. The good question is one, the benefit of lightning. First, that one for farmer. Because of when the lightning strike to the land, the ground, it become the fertilizer. Fertilizer, right? Fertilizer to grow the plant. Good for group, and then they produce ozone to become good for plant. And another one, in the world, we need to research about the harvest energy from the lightning, but we need to do fast switching. For example, when lightning strike, we need to do switching to go to the battery, fuel or what, to the battery, and then come back to ground. Very fast switching, but now in modern technology, we don't have any technology to harvest the lightning now. Very fast. And
Second one, how to reduce the effect of electromagnetic?
Oh, effect of electromagnetic. For my research, I don't use to reduce the EMF, electromagnetic field, but we harvest to detect where the lightning happen. Well, you understand? But in aviation research, they use to eliminate the EMF, because when the lightning strike to the aeroplane at the dome, they need to eliminate the EMF as good as possible, because of the EMF not disrupt the equipment.
Yeah, we got it. I think all the patients answered already. Anyone to ask anyone? Okay. There's not any question, anyone? Yeah. Ya, saya rasa untuk pertanyaan yang dari chat sudah saya bacakan, Prof. Jadi ada 3 pertanyaan sekaligus disampaikan dari penanya yang sama. Cuma yang pertama sepertinya sudah terjawab karena sama dengan pertanyaan pertama. Untuk yang pertama, pertanyaan kedua baru saja dijawab, dan juga pertanyaan ketiga juga baru dijawab. Saya rasa seperti itu untuk sesi ini. Kalau tidak ada yang bertanya, kita akhiri saja kalau misalkan tidak ada penanya. Atau mungkin kita bisa bertanya, Bu. I think if there's somebody want to ask, like, let me be representation for them. Let me ask you about. This is not related to your topic, but I think this is the most important for us. At least we will get a statement from you directly about what is the possibility for us doing research together in future. I mean, of course, it's the research collaboration in future. Okay, this question is for Professor Muzammil. Okay.
Okay. Thank you, Mr. Master Ceremony. Okay. Currently, I think currently I talk to Prof. Currently about my research. I think the one that you can focus on at the moment is, you know, that the technology of 5G is growing up. 5G is going up. Even in Malaysia also, we are aggressively doing all those solutions. And there is some features related that we can explore together. One of them is intelligent reflecting surface, Ir.Ts. Actually, this is the one that I am focusing on. I'm waiting Prof to join as well. We had a discussion before. It's about how you do some reconfigurable on the antenna as well, the beamforming of those things. But now it's known as Ir.Ts. Another one that I already started is about reconfigurable metamaterial. If you can explore, metamaterial is now it's bombing, it's heat because of material as well. material, metamaterial. Talking about reconfigurable, still new. Reconfigurable metamaterial, still new.
So we still have possibility to do.
Yes, still have possibility even to publish in a good journal lah.
That's good information for us. Yeah.
Yes. I had published one in Census lah. Can check. Mostly I publish in MDPI. Okay, another one maybe you can focus on developing the 5G/6D antenna. Talking about 6D still now, Prof, we are wondering what is they want to do. But I think Korea, I had my friends, they have been there recently in a 6D lab in Korea. So they already start something. But we still, but for us, maybe we can still focusing on the 5G antenna. But the antenna, we're talking about millimeter wave now. So we can start together. When we have sub-millimeter wave, sub-wave, sub-band, so sub-I289. Okay, those are the three things.
Thank you very much. Thank you very much for that information. I think that is so important for us. So anyone wants to do research together with him, you say that it's open. Yeah, the possibility is open. Whenever you would like to go to research together with him, you can tell him. I think it was all I can do today, and it was all speaker can do today. And before we close, I think I have to say so sorry for any mistake I did. So sorry for this crew did for this event, especially for the preparation and especially for my bad English as well as my attitude. So I think from me. See you on the next guest lecturer. Time is written back to PS.
Kami ucapkan terima kasih kepada moderator dan boleh kita berikan tepuk tangan untuk kedua speaker, Profesor Muzammil dan juga Dr. Syahrun Nizam. Selanjutnya adalah penyerahan cenderamata atau souvenir kepada kedua narasumber yang akan diserahkan oleh guru besar dari Teknik Universitas Mercu Buana, Profesor Dr. Ir.Ts dan juga Ketua Program Studi Magister Teknik Elektro, Ibu Dr. Muzammil. Kami persilakan. Next, delivered special souvenir from Electrical Engineering Program Master of Universitas Mercu Buana to our speakers. First, pertama dari Ketua Program Studi. Selanjutnya adalah sertifikat. Selanjutnya kepada narasumber kedua oleh Profesor Dr. Ir.Ts diserahkan kepada Dr. Syahrun Nizam. Prof Mudri, kami persilakan, didampingi oleh Ketua Program Studi. Thank you very much. Silakan kembali ke tempat duduk dan demikianlah rangkaian acara pada hari ini. Sebelumnya kami informasikan kepada seluruh peserta untuk mengisi daftar kehadiran melalui QR code atau link yang telah di-share oleh panitia. Baik itu yang bergabung melalui ruang virtual maupun rekan-rekan audiens yang hadir secara offline di ruang Harun Zain. kami persilakan untuk men-scan QR code yang terpampang di depan dan juga atau menggunakan link yang telah di-share di depan, yaitu https://daftarhadir/IJLMTI. Kami persilakan untuk rekan-rekan yang hadir di dalam ruang forensic dan juga kepada rekan-rekan yang hadir di ruang meeting Zoom untuk dapat mengisi daftar kehadiran karena ini akan berkaitan dengan sertifikat rekan-rekan sekalian. Jika tidak mengisi daftar kehadiran atau presensi, maka rekan-rekan dianggap tidak turut serta atau tidak hadir pada hari ini. Kami silakan baik yang bergabung secara online maupun yang bergabung secara offline. Kami persilakan untuk dapat mengisi daftar kehadiran melalui QR code atau link yang telah di-share berikutnya. Well, ladies and gentlemen, finally we come to at the end of International Day lecture today. Thank you for attention and participation, and good afternoon. See you next time. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.